These are American-made McNees to take advantage of MagnaCut's toughness. It's really hard not to love it.
Hi there, knife people, hello lady and gentlemen. You just saw Seth from the Knife Center showing the knife, and I went ahead and I bought the knife. And I don't mean I bought a McNees knife. I bought the knife that he has in the video. In that video, Seth made 3 major points that I just showed you. Number 1, American made. Number 2, MagnaCut, very tough. And number 3, hard not to love. And we're going to talk about all 3 of them, starting with the one I disagree with. He said it's hard not to love it. I say it's actually hard to love it, but love it you will. All right, let's take a close look. And don't worry about it being a little dirty. I just finished testing it. So if you watch my channel, you know what I do. And these tests, unfortunately, make the knives dirty. So first thing I noticed when I pulled it out of the box was this stop pin. It's tiny, tiny, considering the blade thickness. This is a very thick blade. 153, 154 thousandths of an inch. Which brought me to the next concern. This lock bar doesn't have a steel insert. That made me nervous as well. And as you can see, the lock bar stop plate is nowhere to be found, so I can potentially overpress. And so I took a close look and noticed some other sort of simplifications in the design. For example, you can see the fastener. I like that it's a T8 for the frame screw. There's your spacer, and the screw goes all the way through and comes out on the other side. Do you know why other knife makers don't do it like that? Because if you thread it into the spacer and you cross thread it somehow, you're just replacing the spacer. If you mess up the threads on the scales, though, you only have 2 options. I'm sorry, not the scales, the frame, right? And this is the expensive side of the frame, by the way. So you have 2 options, 3 really. Buy a new knife, number 1. Number 2 option, replace the frame plate right here, right? Which is not very feasible. Or drill on top for a larger size and hope you can find a screw that fits. And then you have to drill out the spacers. The pivot is T8. And we'll get to the pivot in a little bit. It deserves a little longer discussion. Action is excellent. Centering spot on. And it runs on a really good bearings there, which I will show you in a little bit. Now, let me get back to the story here. I was that close to actually returning it to the Knife Center. And I would pick it up and put it down, pick it up and put it down. And I just could not let it go. This knife is stunningly beautiful in its simplicity. It reminds me a World War II tank. Maybe a Panzer IV, T-34, M3 maybe, maybe Lee. That's the look this knife has, like an overbuilt simplicity. With the drop point, the important thing to remember is that swedge right here. Some people call it fall edge, but it's really called a swedge, right? And what it creates is this line here, this ridge line is akin to a ridge line on your construction helmet, which absorbs the shock and distributes the stress there and makes it that much more strong. So if you were to sort of slice the blade across here, the cross section would be diamond shape like this. And that's a very, very strong shape geometrically. So I knew the blade will take any kind of side loading. After you see what I did with it, you might be surprised by this. The sharpening tool gets me every time. Anyway, why don't I show you? Here you go. If you are new to my channel, this is what I do. I have this dead oak tree in a little park nearby. And I go in there and I grip the knife as securely as I can, and I strike it 25 times, and then I pry it left to right, right to left, at pretty severe angles to determine if the tip will break. I broke several tips now. I think the count is up to 13 now, and they're still stuck somewhere in that tree. And this is what I do. I don't know if it's scientific enough, but I think 25 strikes average out strength versus angles and all that. I don't recommend you do anything like that on your own. It's very unsafe for the knife and for your hand. But if you're using your knife hard, and make sure that your grip encompasses the lock bar. And I am in the reverse grip, and my last three fingers are squeezing pretty hard on that lock bar, and that's what keeps it locked. When I start hammering it into the stump, you will see it will unlock, and then I'll position my left hand in such a way that it locks it again, and then I was able to proceed with hammering. Why am I doing the hammering? Just watch. Once I'm done knocking it in, what I will do is I'll do a twist test. What it does, it determines whether or not the knife's construction is robust enough to withstand these lateral and twist loads. Especially on a wide handle knife like that, you can actually exert a lot of twisting moment on it. And all the components, especially the bearings, have to be able to take it. And that's why I do that. And you know what happened to the knife? Absolutely nothing. It just took it like a champ. You know, amazing. And now you're seeing me getting this bright idea about batoning and chipping off the corner of the edge of the stump, which led me to a small adventure in a minute. Yeah, it's going pretty well. You know, notice the bite. That knife has an immense bite. It bites in like a pit bull. Now, would I go out there and baton wood and process firewood with this knife? Oh, yeah, I would. This is like, that's the knife to do it with, right? So, the adventure is about to happen. Keep a close eye on what's going on. What? Did you catch it? And that was it. This was one and only failure today. What happened is the thumb studs didn't have enough Loctite, and they worked themselves loose and fell out. Luckily, I had a pretty potent magnetic bar at home, which I brought out to the Tree of Doom. And after about 15 minutes of fiddling in the grass, I was able to find them. Which is a good thing because the replacement hardware set for McNees knife is about 75 bucks. All right, if you with me thus far, it's going to be a little bit dry, but also interesting at the same time, because I called McNees Custom Knives Company and left a message telling them that I did some testing on their knives and I'm creating a video with a review. And I wanted to confirm some information. And as I was filming, Jon McNees called me back, and we ended up having like an hour conversation about knives in general, about details of this knife in particular. It will be interesting to see how some of my findings, how did they line up with what I learned from Jon. I did not ask him permission to record a conversation, so you're going to have to take my word for it. T8 everywhere. That's good. Here, the pivot is not captive, the pivot nut, so you need two T8 bits. I detect Loctite in there. Okay, are we ready to pop? We're ready to pop. Where's my pry bar? Ooh, it's tight. All right, this is it. That's the first time I'm doing it with a McNees. Okay. Steel cage thrust bearing. Core of a thrust bearing. Steel on steel. Awesome. This has been replaced by nylon on many knives. And there are advantages and disadvantages to nylon. But in a knife like this, I'll take stainless bearings any day. We talked about the bearings with Jon, and he said that right now these bearings are sourced overseas. We all know what that means. So going back to Seth's original point about this being US made, it's definitely made mostly in the US and assembled entirely in the US, but there is a foreign parts content, and the maker, Jon McNees, is very transparent about it. The bearings, some of the threaded fasteners here are Chinese made, and he's working actively pursuing making them in the United States. And that pin, oh, it's captive. That's great. No, it's not. Okay, but it's a slip fit, if you know what I mean. Very, very tight. It's not quite interference fit. It's not pressed in, but it's a very tight slip fit. So let's get a little bit into the knife engineering here. So here's your pin, and this is the scale, and this scrap of paper is representing the scale, right, in this orientation. So that's the scale, sorry, right there. And that's the pinhole, and it's a blind hole. It doesn't protrude on this side. So if I had a traditional shoulder pin, which looks like this, cross section, right? If I sliced it in half, and it would fit in a hole like so. So it would bottom out on these shoulders right here. Right here. This is what's called the shoulder. Okay, and so if I applied some kind of force to it, to the blade, in this direction, but usually it's not straight on, so there'll be some kind of rotating moment here. The pin would tend to rotate this way. Obviously, it's not to scale. I'm exaggerating the gap, but the pin would eventually orientate itself like this. And see, even with paper, the shoulder is preventing me from rotating the scale. So all the stress would be focused right here. And obviously opposite, diagonally opposite on this side of the hole. If I twisted the handle this way, then all the stress will be in this area. And shoulders are there designed to create that distribution of load. If you choose to do what Mr. McNees did, which is a slip fit pin, means it's going to go in, but it's going to be very tight to the walls of this hole. So think of the hole as a cylinder, so the entire cylindrical surface makes contact. So when I apply pressure this way, it immediately, this rigid assembly here does not allow it to move very far. And therefore, most of the stress is concentrated along this surface. And depending on the direction, it's probably distributed like this. So this is this red area represents the stress. So as you can see, unless I make this shoulder pin very wide, the cylindrical surface gives us a lot more area of contact than the shoulder. Bottom line is the strength of this whole connection will depend on how tightly the pin fits and how hard the pin is itself. And I'll get to the hardness in a little bit. And here's the blade. Nice deep detent. Detent is hidden. In other words, when the knife is deployed, you can't see the divot here. and that's important because that has less chance to get debris into this divot, and then your knife won't function properly. And here's an example of a knife where the detent divot is visible on the exterior of the scale or the frame. And if I got it dirty, it potentially would interfere with how the detent works on the knife. This jig finish, it's called jigged finish, kind of as in a jigged bone on the older knives made out of horn or bone. This jigging is done also by a CNC machine, so it's repeated from knife to knife and not unique. So potentially Seth might have been holding a completely different knife. So I was just wishful thinking on my part. So Seth, if you're watching, would you please let me know? I'm really dying to know if your famous hands touched this knife that I acquired. I just, like 3 minutes ago, decided I'm going to keep the knife. I'm going to return it. Keep in mind that at this point, when I was filming what you're seeing right this minute, I have not tested the knife yet in a Tree of Doom, and I have not spoken yet with Jon McNees. This is HRC 60 test file. So I'm going to find a nice shiny spot here where you can see what I'm doing. Okay, so this is 60 Rockwell. And it doesn't do anything to the blade. That means the blade is harder than the 60 Rockwell file. And this one is marked 65. They don't go higher than that. That's the highest one. And it barely sort of smooths the machining marks here. So there's no, barely. The accuracy of these test files always comes into question, but my set is actually made in Japan, not a cheaper Chinese set. And I haven't found any discrepancies yet. I'm going to say this blade is heat treated to at least 63 HRC. And the ideal zone for properly heat treated MagnaCut is right there between 63 and 64.5. This is pushing the upper. Take a wild guess what Jon McNees told me he's heat treating the blades to. 63 to 64 Rockwell hardness. He also told me he outsources the heat treat. He sends the blades out. But, and here's the most exciting to me as a steel nerd part, the company that does heat treat on these blades is the same company that makes calibration blocks for the Rockwell hardness testers. So these guys are certified to make steel blocks that machine shops use to certify the Rockwell hardness testers. Literally, this blade is heat treated by the best of the best, and I'm very excited about that. Can you tell? I had a lot of comments when I first started showing these tester files on my channel that they are not accurate. They're plus or minus 5. They're not plus or minus 5 points. They're within 5 points. That's what the manufacturer says. And this particular manufacturer right there, made in Japan, they actually hit it spot on, as you just saw. We're within maybe a half a Rockwell point here. So I am an independent reviewer, and I'm trying to support my channel, so I'm going to throw an Amazon link to these files. And then I also tested this pin, which was my concern. Here's 60. 60 skids right off. 65 creates these smoothed out pattern there. This pin is the same hardness as the blade. So now it all starts coming together and making sense because the pin is deeply recessed in the frame right here. And when the blade engages it, all the stress will be absorbed by the frame. And now the only other area of concerns that I had that needs to be still addressed is the fact that the lock bar doesn't have a steel plate and you getting a hardened blade engaging titanium in that blade tank area. So what I did here, I marked the blade engagement area with a permanent marker, and you can see on the right side the blade is wearing a pattern against the lock bar. So when this lock bar engages, it wears this pattern. And by looking at this pattern, you can tell how good or bad the engagement is. You see what a large area that is cleared of permanent marker? That means the engagement is pretty solid in that area. So the reason mass production knife makers or large batch production knife makers put a stop plate right here is because they don't want to spend too much time on the production line trying to fit the blade to match as perfectly as you see here to the log bar. It's a perfect connection there. And not only that, but if you noticed, the grinding on the tang of the blade is a little bit cylindrical. So if you want to depress the log bar a little farther in, it will go without breaking contact. So, and that's what Jon and I were talking about at some length. So he is trying to minimize the number of parts that go into this knife, because the more parts you have in any mechanism, in any machinery, the less reliable it is. And by the way, Jon is not the only knife maker, knife designer who feels that way. Here's the hoback that I have with my favorite compass pattern. And they don't have any kind of backing plate to their blade. And this is Slim MIDI by Medford Knives and Tool, and this one doesn't have that. Okay, so I guess it wasn't the last feature that I wanted to address. As you can see, these two knives right here and here have an over travel stops for the lock bar, so they prevent lock bar from being over pressed. If you're nervous, in a hurry, wearing heavy gloves, you can accidentally overpress it. And then that if you permanently deform this area here, it will not engage the blade correctly. Jon said that he considered it. It wasn't in line with his understanding of a knife's aesthetics and functionality. And in the 10 years that he's been making production knives, he had not a single failure where somebody sent him a knife with a bend spring. If he does change his mind, this approach to me is more elegant than this approach, because you can see the pivot center is very close to the log bar on this knife, and all he would have to do is, sorry about the focus here, all he would have to do is extend the flange. I think that's also very important to tell you this little story. So if you look for an interview with him on YouTube, there's a SHOT Show, I think, interview where an interviewer asks him, calls him a custom knife maker. And Jon says, well, full disclosure, with his beautiful southern drawl, he says, full disclosure, I am not a custom maker anymore because I have employees now making knives. And so I asked him about that, and he said, well, I have 6 employees, and if you count my wife and I, there's 8 full-time employees in my company. No way in heck, any other knife maker that I seen interviews with or personally talked to would say their production knife maker if they total company's 8 persons strong. So he's just being transparent and honest, which is a very refreshing trait in today's world.